Hi, today we're going to be talking about EDA and dealing with dirty data. If you haven't already viewed the course that we have on the Introduction to EDA, you may want to check that out first to make sure you have some foundational concepts down before you delve into this one. I'm Tim Snyder. I'm CSE manager with Rocket Software, and my team provides delivery services for Rocket's multi-valued customers.
Here's some links you might find useful if you'd like to follow along with the demos. We have the XDemo account for Unidata and Universe, and we have it for Windows and Linux. There's also the EDA Schema Manager, which is used quite extensively in these EDA demos, and the edacheckx utility, which we'll be using to scan for and help you repair dirty data.
So what is non-conforming data? Well, the U2 databases are really forgiving when it comes to data typing. You can have a date field that contains ASAP. You could even have a dollar amount that contains some sort of text. And if a field is longer than its defined length, the programming languages and the query tools don't have a problem with it. They'll deal with it, no problem. However, SQL is very strict. Yeah, any of those previous examples, a data field is too long, a date that contains ASAP, yeah, any of that is not going to work well in the SQL environment. And if any of that is encountered, it will be marked as non-conforming by the EDA engine. Also, just something I found out the hard way, is that in SQL, any date before 1900 is not allowed. So if you do have any dates in your database, whether intentionally or accidentally representing dates that old, they will be tossed out by SQL. And it's not always easy to kind of understand why. And that's, like I say, a lesson learned the hard way. So how do we deal with non-conforming data? Well, when EDA identifies a row that contains non-conforming data, that entire row is nulled out. Every column on that row is nulled out. And then there's a special column at the end that's non-conforming. It's a yes or no question. And if it's set as non-conforming, that means something is wrong. However, it doesn't tell you why it's wrong. Why is this row marked as non-conforming? It doesn't even tell you which column or which field created the problem. So it can be kind of hard to figure out if you have a large record, 400 attributes. Well, one of those, or at least one of those, created something that SQL doesn't like, but you don't know exactly what. There is an ECL or TCL command called select.eda.nonconforming, which will create an active select list for any rows or records that are non-conforming, but it still doesn't tell you why they're non-conforming. Okay, so once we've determined that we have a problem and we know that the row is non-conforming, how do we determine why? Well, we provide a free tool called edacheckx. You can get that tool by looking at the GitHub information that I provide earlier. You can download that for free. edacheckx will examine the data in a non-conforming row. It actually looks at the entire file and reports on likely reasons that it's non-conforming. So do a quick demo of edacheckx, and in that demo, we'll take a look at the initial configuration, the setup of the tool, how we examine a file that contains bad data. I'll intentionally create some so that we can see what happens. Then we will run the edacheckx to recommend some changes. We will make those changes in the schema generator and reconvert the data using the EDA convert command from ECL or TCL. And then we'll show the results. We'll do a select EDA non-conforming to confirm that, yep, we got it all, and there are no longer any non-conforming records in that file.
Now here's the edacheckx utility. So it asks us to log in to the server and the account we're using with our login credentials. So I'm going to go ahead and do that. I'm going to log in as Unidata because that's what I'm working with here. And it'll take a second to get in and connect me. And when it does, it sees that I was previously working on the members table, which is good because that's the one I want to be taking a look at. We can do a lot of different things here, but I'm going to just focus on this, on checking the validity of the members table. So I'm going to say select all, which will select all of the fields within that particular file. And I'm just going to say check all. And when I do, oh, it found 2 problems. Well, that's okay. I intentionally did that. I created some issues. If I click into this, it will pop up a little window with some additional information. So we see that the first name in location 2, in other words, attribute 2, the string is too big for its setting. And then it lists the data that's in there, and it shows me that it is, in fact, 37 characters long. So we'll need to take a look at that. And then we also have a birth date field, and that contains some invalid information. This is not a valid date because it has an X in it. So we'll take 2 different approaches to this. Let's fix the birth date one first. So that was in number 3. If I would edit members 0003, I go to the birth date field, which is 10, and get rid of that X. If I do that, let's go back in and recheck with edacheckx. Okay, that got rid of that date error. So we fixed that one by fixing the data. Now the other one, this field length for the first name, well, maybe that's actually valid. Maybe we want to allow that many characters. So instead of shortening the data in this case, we're going to go in and change the definition. We're going to go into the EDA schema manager for that first name. We see this defined as 20 characters. Well, we know that it had 37 because that's what edacheckx told us. What I'm going to do is I'm going to just go ahead and change this to 50. And then I'm going to go ahead and save my definition. And I'm going to reconvert that file. I'm going to go in here. I'm going to need to click the force drop because I know that the tables already exist out there. And then I'm just going to EDA convert that file. It's going to suspend replication just as it had done the first time around. Then it will convert the records. And then when that's done, it will resync replication. And now it says, okay, we got 2,500 records transferred. Let's go back into edacheckx and see what that has to say about it. You know what I need to do? I need to disconnect, reconnect, because we have a different version of the file out there now. Select all, check all. And there we go, no errors were found. So that's how we can identify problems within the database definition and or data, and then determine how we're going to fix it. Either fix the data or fix the definition.
So it can really take a long time to convert a file. If it contains millions of records, you might be sitting there for hours as it converts it. It's a one-time thing, but it can take some serious time. If you wait hours to go through all that and then just discover that, oh, well, I had some non-conforming data. We had 3 records out of 3 million or whatever. You'll still need to go back and deal with those. You'll have to update the schema and then reconvert the information. So we recommend starting with a subset of the file's records to make the initial conversion faster. So I like to make another copy of the file that contains a small number of records, maybe 1,000. That usually seems to work pretty well because 1,000 records will convert pretty quickly. If you can get it clean with that small number of records, bump it up. Try for some more. When you think you've got this thing nailed and you've identified the possible causes for non-conforming data, go ahead and copy in all the records and do a final check for non-conforming data. So here's how I like to do it. I will rename the original file and create a vote pointer to it. So if we're working with a customer file, it might be called customer.orig or customer.full or something like that. Then I'll create a new and a smaller version of the file. Just call it customer in this case. And then I will select and copy 1,000 records from the main file, the customer.full in this case, copy those 1,000 records into the small file. Then I'll map that small file for EDA. I'll deal with whatever non-conforming data happens to be in there. And once I get it clean, now copy in 5,000 records and then check for non-conforming data. And then, keep bumping it up until you feel comfortable. And then, yep, I think we've got this nailed. Let's go ahead and copy in the entire file. And then we will check for non-conforming data.
So for this, I created a file, cleverly called Big File. It has 10,000 records in it. Yeah, not very big compared to some production files, but for the sake of a demo, it gets the idea across. So let's say we have that 10,000 records. This is a brand new file. We're going to be mapping it for EDA. We don't know what the situation is as far as non-conforming data, or, how good are our field lengths and so forth. So we'll just go ahead and we'll play around with that. But rather than converting all 10,000 records, maybe we start with 1,000. So the way I handle that is I'll just go ahead and I'll just rename Big File to bigfile.full. It can be anything, but I kind of like the .full because that kind of tells you this is the full version of the file. So now we've renamed that file to Big File. We don't have Big File anymore, but we have Big File.full. With our 10,000 records. Now we're going to create a little version of Big File. And we'll go ahead and we'll just let it be named Big File because this is how we're going to be working with it. We're going to be setting up our schema based on this name, not the Big File.full. So we're going to go ahead and create Big File and, whatever, 101, 2 dynamic. All right, so now we have that file. Now here's an important thing you need to remember. Copy in the dictionary items from Big File because that's what we're going to be using to map this thing. So we're going to copy from dict Big File.full to dict Big File, all overwriting. And in this case, we don't have a whole lot of dictionary items, but that's okay. You get the idea. And so now we have an empty file called Big File. We're going to go ahead and just copy in 1,000 records. Select Big File.full, sample 1,000. Now we have an active list of 1,000 records, and we're going to copy from Big File.full to Big File. Now we count Big File, and it has 1,000 records. And then that's what we can use. We can go ahead and map this thing for EDA use, get the schema going, and convert it for 1,000 records. And we may find, oh wow, you know what? We really need to increase the size of the address line or something like that. So go ahead and fiddle with that, get that thing worked out, or maybe say, oh wow, we have a consistent problem with one of these fields, but you know what? That's maybe not useful information. Let's just delete that field. It doesn't need to be a common SQL, whatever we're going to do. And then we work with it with that 1,000 records. Okay, when then that's ready, let's copy in 2,000. Before I do that, I'm going to clear file, Big File, and then I'll go ahead and sample and copy in. I could have just copied in with the overwriting option, but if it's something that's already mapped for EDA, it's much quicker to do a clear file because that just kind of cleans out the files in one fell swoop on the SQL side, and then we can go ahead and copy in the records. So then we can select Big File.full, sample 2,000, and then copy from Big File.full to Big File. and now we have 2,000 records, and so on and so forth. To go through that cycle when it looks like we're okay, and yeah, I think we've gotten the data definitions pretty well lined up, and we've identified potentials for dirty data, and we know how to deal with them. And then just slowly increment that until you get to the full complement of records in big file.full. Copy that over to big file and go ahead and do a final conversion, and there you go. You're done and you're ready to go.
So thanks for viewing this. There's some other courses you might want to check out related to EDA. Thanks a lot, and we'll see you in the next video.